Hello everyone. So I'm going to be doing a walkthrough of the empirical formula worksheet. If you're a part of my Canvas course, it's going to be in Canvas, and if you're joining me through YouTube, this PowerPoint will be in the Dropbox link along with the worksheet I'm referring to. This problem comes from the percent composition empirical formula molecular formula study guide worksheet, and the answers to that worksheet are also posted as a separate document. And the link to the video will be here after I make and upload the video to YouTube. So, empirical formulas. With the empirical formula, you want to get to the lowest subscripts you can get. And number 1, SO4, is a polyatomic ion. So that is all together, and we're going to have a subscript of 1. Even though we don't normally write the 1, this is just to help you understand why we're not going to change this, because we treat this as one unit. It's going to stay the same. When you get to 1, you know you're already at your empirical formula. So this is going to stay as Na2SO4. Now, if you had Na4 SO4 2, right? You can divide these both by 2. Right? You would leave this the same, and you would get back to that empirical formula that you were originally given in Na2SO4, because this comes out to 1. Right? So in this case, number 2, we can divide these all by 6, which is going to be C1, right, H2O1, or CH2O, because we don't write the 1s. This one, we can divide these both by 2. So you're going to have C2H5. This one, you could put a 1 here in front of the K. So this is already at the empirical formula. Whenever you have a subscript of 1 on anywhere, you are already at your empirical formula. So that stays the same. And here you can divide these both by 2. And then you would get H1O1 or just OH. Alright. Propene has an empirical formula of CH2. What is its molecular formula if it has a molar mass of 42.09 grams per mole? So when you're going from a molecular formula to an empirical formula, we're going to use this formula to figure it out. You take the molar mass of the molecular formula and put it over the molar mass of the empirical formula. Alright? And so you were given the molecular mass of the molecular formula, which equals 42.09 grams per mole. You are also given the I wrote that first part backwards. You are getting the molecular formula. Sorry. You were given the empirical formula. So you're given the empirical, and you're going to molecular. Sorry. Wrote that backwards. You are given the empirical formula of CH2. So you're going to go from the empirical formula to the molar mass of the empirical formula by calculating the molar mass of CH2. I've already done this several times in class, and so if you don't know how to do this, I would suggest you go back and watch the Chapter 2 videos. So when we use this formula here, so our molecular formula we were given They are definitely having fun over in the office next to mine. They're having a party over there. This is our molecular formula molar mass. And then when you calculate this molar mass, you're going to get 14.03 grams. And this comes out to about 3. Or it comes out to 3. So what are we going to do with this 3? Well, we take our empirical formula, and we take those subscripts, and we're going to multiply them by 3. To get, as our final answer, C3H6. Alright? And so when you're going from imperial to molecular, you're going from the lower to the higher. And this is the formula you're going to use. Okay? So, this is the one I had a little bit of a brain fart on today if you're in my 151 Fall 2022 class. And so, what we're going to do is we're going to take the number of grams of each thing and find the number of moles. Whatever the lowest number of moles is, whichever element has the lowest number of moles, we're going to make that a subscriptive 1 by dividing it by itself, so that way we make sure we get this empirical formula, and I'll show you what I mean. And so if we're going to find moles of carbon, so we have 0.3911 grams of carbon. Right? Remember, with unit conversions, I'm trying to go from the partner I have, the loser boyfriend I have, to the husband that I want, right? And so I have to go from grams to moles. So I have to take my loser boyfriend, get him to date someone that's on his level, right? Which is obviously below mine. And because it's below my level, I have to put grams in the denominator here to make it across from each other, so that way they will cancel. And so I put 1 mole of carbon in the top because that's the husband I want. And what do I know about 1 mole of carbon in terms of grams of carbon? Well, I know 1 mole of anything is the molar mass from the periodic table. So what is the molar mass of carbon from our periodic table? Alright, and these will cancel. Right, because I'm getting rid of that loser boyfriend. And I'm looking for moles, right? And moles is the only unit I have left. Alright, so here we're going to get 0.03256 moles of carbon. And we're going to do the same thing for hydrogen and oxygen. We have 0.0654 grams of hydrogen. And we're going to do the same thing for oxygen. Ooh, what did I just do? Okay, not sure what happened there. Alright, so remember, we want to cancel out grams, and we're looking for moles. Right? So multiply across the top, divide by the bottom. Alright, so remember when I said we're trying to get to our empirical formula? So we're going to look for whatever has the smallest number of moles, we're going to make it have a subscript of 1, which means we're going to divide it by itself. So what is the smallest number of moles that we have? Well, that would be carbon, right? That's 0.03 blah 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 is lower than 0.06 anything. So that's why we divide that by that same 1 each time. Uh-oh. That's what happens when you're learning how to use a new system. Alright, we're going to try it again. Alright. That's why we divide by that small amount each time. The way I learned to do this was a little bit harder, that involved more math, which is why I had a little bit of a brain fart, because I was like, this looks too easy. But at least you guys get to learn an easier way of doing this. So, remember this is 1 because we're making it 1 because it's the smallest. So you have 1 mole of carbon. This comes out to 2 moles of hydrogen and 2 moles of oxygen. And these are our subscripts. Again. I'll get there eventually. Subscripts. Right. So we have CH2O2. And that's how we get number 7 on that worksheet. Alright. So the molecular mass of the above compound, and that was CH2O2. So we have the empirical formula. The molecular mass is 276.2 grams per mole. So what is the molecular formula? So this is a lot like the first problem we did. When we're going from molecular to empirical formula, or so I said it backwards again. We have the empirical formula, we're going to the molecular formula. Right? So in order to do that, we're going to use, again, this equation, the molar mass of the molecular formula over the molar mass of the empirical formula. This is given in the problem. This can be found using the empirical, this can be calculated using the imperial formula. Alright, so let me change colors. Alright, so the molar mass of our molecular formula equals 276.2, let's put a decimal there, grams per mole. And the molar mass of the empirical formula, you can calculate on your own. and we get the number 6. What do we do with this number? Remember, in this problem, when we got this number, we multiplied our subscripts by that number. So our empirical formula was CH2O2, and we're going to multiply each subscript by 6. So remember, the 1 is implied here, right? And now we're going to multiply by 6. And so our answer is going to be C6H12O12. Alright, so on to the next problem. A compound, and this is the last problem in that worksheet. The other problems are similar to the first two. This one's a little funny because we're going to get 1.5 as a subscript, and we'll talk about how to deal with that. It's very straightforward. Alright, so again, we're finding the empirical formula by taking the grams and finding moles. And so you want to find chromium on the periodic table so you can find those molar masses. So you're going to have 7.35 grams of chromium. And we're going to figure out how many moles of chromium in that is. And we're going to do the same thing with oxygen. Oops. And if your numbers are a little bit different because in the worksheet it says 16 instead of 15.998, don't worry too much about it. Now when we got to this part in the last problem, what did we do? We figured out which one had the smallest number of moles because we needed to make that 1. Right? This one has the smallest number of moles. So we're going to divide it by itself to make it 1, and we're going to divide the bottom by the same number. To get that ratio we're looking for. And our subscripts are going to be Lord have mercy. Give me strength. Alright. We're going to have 1 mole of Cr because we divided it by itself. And we're going to get, oops, I wrote that wrong. It's supposed to be oxygen. And we're going to have 1.5 moles of oxygen. So how do we deal with that? Well, the best way to get any number that has a 0.5 in it to a whole number ratio is to multiply by 2. So we're going to, what we do to that one, we have to do to this one. So we're going to multiply both things by 2. And so we get 2 for Cr and 3 for oxygen. So we're going to have Cr2O3 as our answer. And so the other few problems, you can go through and practice those. There's some practice problems if you want to look at Khan Academy. There's practice problems about this all over the place. So this is just a short, brief walkthrough to get you to be able to do those other problems on that worksheet on your own. Again, the key is posted for that. So good luck.